Mr. Crispin Enterprises. Thank you for returning my call, pharmacist. Yes. Now, what it is, it's about my brother. Yes, now, he and I were out on a walk yesterday, and whilst we were out and about, he got bitten on the arm. Now, I was just phoning to see if you could suggest how I might treat him. Yes, mosquito cream, midge cream. I can give them a go. Sorry? What bit him? Oh, a lion. Good idea. Mr. Crispin here once again, and welcome to my workshop. Now in today's video you're going to see the completion of my Harrison 190. By the end of this video it will be all back together, all its bits will be reinstalled and it should be operational. Now I'd be more than happy to get straight into that, but I have had a recent absence, and following quite a few messages I've had, I thought I'd better offer some kind of explanation to where I've been. Well, basically I've just been thinking and I've decided machining isn't really for me. Only joking. No, I'm afraid the reasons are more boring. Those of you who have been around here for a while will remember that at the time I took this workshop on and started turning this garage into a workshop, I also took on the renovation of a house. That happens to be the house that's just there, and that happens to be the house I live in. Now when I took all this on as a project, I prioritised the setting up of this workshop and my return to YouTube ahead of other things, and as a result I've now produced 35 videos from this workshop, which is more than my previous workshop. So from that point of view, prioritising this line of work was a success. However, that of course does leave all the work still to do on the house. Now I've been working away at it for a few years now, and there's been good progress. My recent absence was on the basis of a carpet fitter coming, and I had to finish the upstairs, the stairwell, hallway, porch, and there was a lot to do. So I did not plan to be totally absent. However, the way timings transpired, I had no choice but to just get on with it. So I didn't set foot in this workshop for 10 weeks, and when I did get back in, it's taken me a further 4 weeks to complete the work you're going to see in today's video. So I'm not going to apologise, but I would like to take a moment to say thank you to the viewers who keep turning up. I know some of you have been here a long time across a number of my absences, and I'm always grateful to see people returning and viewing the videos, although I of course don't take their subscriptionship for granted. So that's quite enough of this nonsense. Let's get to the lathe. Well, some time has passed, but here I am, and I'm ready to carry out the reassembly of this. Now, as you'll remember, these are all stuck and I sorted them out. In doing so, I had a couple of casualties. These pieces with the tenons on, I had issues with. One sheared off completely, and on another one, cracks started to permeate in the corners where they'd been under some load. So what I've done is I've taken them, filed them off flat, and then drilled and Loctited some pins in. Now perhaps slightly less strong than the original design, but in this clean and oiled condition these will be more than strong enough to carry out the adjustments, and should in 20 years they be stuck and these snap off, well, the original design broke anyway, so I'm quite happy with that as a repair. Now also I decided it would aid me to make an adjustment tool, because these cap heads sit in there, that goes in there, and somehow you have to be able to rotate the piece and also do the cap head up. So I've made a little tool which allows the rotation and also access with an Allen key. So I'm pretty much ready to go back together. Now as I have been conducting this reassembly and cleaning of all the bits, I've been examining the condition of everything, and you saw me do some work on the bed. Well, I've only found one piece that really needs any work, and it happens to actually be part of this assembly. The saddle gibs that sit under here and run along this surface are in a slightly questionable form. They appear to have been hand scraped on the working surfaces, you know, these working surfaces that slide along, but the contact patterns are very poor. You can see in this one, got a tiny section here and then a bit more of a section there, but compared to the surface that is designed to run, it's not a lot. Equally, this one it just doesn't quite look right. So before I do this whole reassembly, I'm going to do a little bit of grinding and I'm going to sort these out. Here at the surface grinder, the spindle has been warming up and I've got a balanced and dressed wheel on there. Now here's what I'm going to do. I want to grind the surfaces that you can see here that I've just described. However, to hold them there is complications. These are cast objects, and to try and hold them in some kind of vise would involve a lot of setting up, trying to get them parallel and square. So I'm not going to bother. What I'm going to do, I'm just going to reverse them. I'm going to grind the backs to give me a work holding surface, and then I'm just going to reverse them and hold them on that surface, and then they are in prime shape to be ground. Now that's quite straightforward. The only thing to mention is that in the case of this one that has the step, there is a chance that as I grind it, it tries to rock. So I've just knocked up a couple of little wedges and I'm going to position these under the edge so that it can't rock. So I have ground up enough of a surface area on both pieces that I can hold them upside down, and I will now proceed with grinding the top surfaces. The only added complication being that on this piece I've got to grind into the corner. Now that's why you saw me dishing the wheel with the dressing stick, but also when I set these up it means I'm going to have to run an indicator along that edge and get it parallel with the axis of the bed. Now currently with them both slack, it slides fine. Now if I just pick one of them and bear down, it still slides fine, so I'm going to start pulling this up until I feel some resistance. Right, that's nipped it, so now I know I can just back off ever so slightly and it's just moving. Still just a hair tight. That's pretty good. Now I know that this whole arrangement is set, so the trick is now to release this one altogether, to take it out of the equation and repeat the experiment on this side. So with this fully locked down, it's pinched it, and I know that because I slackened this, it's got nothing to do with this one. Right, not far now. Go back the way a touch. Right, I think that's about that. It is now time to install the apron, and I have dragged the saddle all the way down here such that it's overhanging. This is going to allow me to fit the saddle without interfering with the shaft for the on-off lever. Right, so to do this I've got some bits of wood. And in goes the saddle, just into a position where it's balanced. And it's roughly where the holes are. Now the main job here is to get the oil feed pipe connected up. Now that's that, and now as I operate the pump you can see some air bubbles moving. Okay, right, now to do these 4 bolts that go in through the top, and see if I can push another piece of wood under there. Yeah, that's in the lift plan, I think. The right hand knee. Right, hopefully I'm within reach of the cap heads. You can see that the gibs are much tighter at the non-worn end, but that I'm afraid is inevitable with older machinery. And the hand wheels turn once again. Next up, the various shaft assemblies. In front of the camera now is the cross slide. Now I've had a little surprise. I've put this back on here with minimal oil, and I've actually discovered that it rocks slightly, as you may be able to hear. Now I'm just for a sanity check going to take this off and clean it all again. I was pretty happy it was clean before it went on, but perhaps a burr has fallen out from somewhere. Let's have a look. Well, everything is nice and clean and lightly oiled. I don't want too much oil on at this stage or it hides things, but I can't see anything that would have caused it to rock, leaving only the geometry of the ways as potential causes. Interesting. So there is a rock corner to corner from here to here. Nothing this way, but there is a rock this way. It is worth mentioning that for a large proportion of this lathe's life it has had a hydraulic tracer mounted on the back here. That's a very heavy unit, and perhaps the weight of that has induced either irregular wear or distortion. I'm not quite sure what I'm looking at here in terms of the cause, but the result is definitely some kind of mismatch between the profile of the slides. Now at the end of the day, this is why people rebuild old machinery, either by scraping or grinding normally, and this kind of error would be taken out by following those processes. I am, as I said, not really trying to rebuild this. I was hoping to just overhaul it, and adding to that, this is just too long to fit on the surface grinder. Was it a bit shorter, I could attempt to regrind this top half. Who knows where the error actually is, but I could have reground this, the ways on this top half. What I'm going to do is I'm going to reassemble it. I'll put some whey oil on, I'm going to put the gib strips on, and then I'm going to see, first of all, are the gib strips powerful enough to overcome this error, and if they are, how much extra friction does that then induce on the slideways. Now, to put this in context, I've done a bit of analysis with the older feeler gauges, and checking on this flat portion at the back with this pressed down, 3 thou is the magnitude of the error. So with 3 thou, there's just a bit of resistance on there, so that's the kind of error we're talking about. Assembly of the cross slide begins, and first of all I've taken the lead screw and I've set the tension of the lead screw nut with these 2 cap heads to get an appropriate fit, and now that this is set, I can remove it, install it on the cross slide, and then it will become encapsulated. Now those of you who saw the video I did on choosing materials with Richard may notice that as far as friction pairs go, here's an example of bronze on steel, and having examined it, the wear properties appear to have been quite favourable. So there is another example of a friction pair in action. I will now proceed to do this all in fast forward. Just a little observation. Here along the cross slide, all the way down the length, you can see tapped holes. Now these tapped holes are for retaining the plates that hold this to the saddle. Now there's nothing wrong with that, however these tapped holes, as you can see, have been done in a through hole style, so they're not blind holes. The hole comes all the way through, and it actually breaks out along the running surface of the slideway. Now okay, the burrs aren't an issue because the burrs have been stoned off, and I assume they were at the time of assembly as well. However, you have to be very careful with the further assembly, because all these cap heads are going to come in through the side, and I have gone to great lengths to clean, and in some cases re-tap and then clean again, the tapped holes and the threads of the cap heads. If you don't, even if you've cleaned everything, when you come to do all these cap heads up, any dirt that's in there is just going to get forced into the slideway. So slightly questionable design, but I've just had to try and get around it by cleaning everything. I have completed the setup of the cross slide with regards to its sliding motion, and as you saw, that was done by means of adjusting these vertical cap heads and these horizontal cap heads. Now the design is straightforward. The cross slide sits on top of the way, and it is retained from any lifting motion by means of these angle pieces that come in and act upon this horizontal surface underneath the slideways that I'm pointing at. Now, one thing to mention is the finesse of setting these up. The main adjustments are, of course, the vertical cap heads. They pull the angle pieces upwards until they are just making contact with the slideway. However, what I found is that when I came to tighten these from a nipped to a fully tight state, they actually caused the angle pieces to clamp on harder and thus lock the slide up too tight. So that is where this device came in. basically I was having to slacken the odd cap head, and then to make the piece go down again I was just going tap on the top of the cap head. Obviously if you slacken it, all that happens is the cap head comes up, and because this is being nipped from the side it doesn't go anywhere. So the method I found that worked was to occasionally tap them back down when required, and I've got it to a position that I'm happy with. Now for the fun bit, and that is to reassemble the cross slide hand wheel, lead screw and bearing assembly. The machine now has a working cross slide, and I just wanted to follow up on the issue of the 3 thou rocking. Two things to say. Number one is, once I put a thin film of oil on, that rocking was almost undetectable, and I'd go as far as saying if I had given it all the good oiling up before I put it together, I probably wouldn't have even realised it existed. So that is partly why I put it together with no oil, just to see exactly how everything sat. But with the oil it was much less obvious. Second thing to say is that once I did these cap heads, I then repeated the check with the feeler gauge in the back corner, and I found that even a 1 thou feeler gauge wouldn't go in. So basically some kind of twisting has gone on, but it doesn't appear to be presenting any additional resistance, so I'll just have to see how it goes, and I will now proceed with the top slide assembly. Exhibit A top slide in motion. This is now complete, and I thought I'd point out that these brass nuts are not original. The original nuts were missing, so I've made some new nuts and a collar to try and stiffen the handle up a bit, and that is all working quite nicely. So that is one top slide complete. Well, personally I think this is starting to look like a lathe. As you can see, I fitted the chuck. That was cleaned up, all taken to bits. I cleaned the scroll, cleaned the internal bevel gears, cleaned the jaws, etc., re-greased everything. The slideways are all operational, as you've seen, and everything's moving freely. I've also fitted a few more little bits. I've done the saddle lock and I've done the cross slide lock. Now that almost brings the reassembly to a close. I've still got to do the tailstock and the just threading attachment, but before I put those on, I'm actually going to plot out how I'm going to install the digital readout. And once I've worked out exactly the locations, I'm going to make some bracketry, drill and tap a few holes, and then I'll show you some brief clips of the installation of that before finishing off with a few final details. I have been working down here for some time now, and let me show you what I've been up to. I have mounted this aluminium rail that the digital readout screws to by commandeering the top row of tapped holes on the back of the bed. Now, I mentioned that this machine has a hydraulic tracer, and that bolts on using these pairs of holes. However, I have had a bit of a think, and I believe that I can mount that tracer in an alternative way when the time comes by using just the bottom row of holes. Now, that is not an imminent project, but I want to make sure that when the time does come, the option is still here. So what I have done is I've kept this digital readout as high as possible to allow them to both operate in tandem. Now, the only downside of that is I've had to get this that high that I've lost some access to the adjustments for the rear saddle gib, but I think that's a small compromise for the ability to have the readout and the hydraulic tracer at some point. So on with the installation, and what happens with this is the digital readout scale fits as follows. It sits on this rail and then bolts on at either end. Over the front of this goes a cover plate, and then over all of this will go a piece of bracketry that comes down off the back of the saddle and goes to the reader. So the scale stays still and the reader will go up and down with the saddle. You are now looking at the inside of the saddle, and you are also looking at my misdemeanor where I left a paint and has rag and melted some paint. But I'm here to talk very briefly to the intricacies of mounting a cross slide scale. Now, compared to the bed longitudinal scale, there are more hazards involved with this, and I'm going to discuss some of them. In an ideal world, you might be able to mount this within the actual cavity of the cross slide. If you had, you know, a big centre casting with a big cutout, you could perhaps mount this inside somehow. If you could do that, it's well out of the way, it's not in your way, and that would be a good all-round solution. It is, however, not a solution I am pursuing on this particular example. Now, I have seen on lathes of this size the cross slide coming out of the back. Handy because it doesn't obstruct any turning, it doesn't obstruct the tailstock, but in my opinion it's too vulnerable. You've got this hanging out of the back, and even with substantial bracketry, it's still in a position where it could get bashed or deal with big bundles of swarf, you know, tools falling off. So for me, I think that's too vulnerable. Equally, if you were to try and do the same by bringing it out at the front, I think that's just totally impractical. So really, we're left with three options, either on the top or on one side or the other. Now, the top, okay, it could be bolted well down, you could make a cover, but it's going to start significantly limiting the diameter of work you can have over the cross slide. Now, all these things of course are, you know, down to the proportions. If this was on the Myford, you would have massively limited what could come over the cross slide compared to without. On this lathe, okay, you probably lost 10% of it, but it's still a fairly large number. That leaves two options. You could put it round the front here. You are not going to massively limit the over cross slide dimension, and the tailstock can still come fully up, and it's well supported by the cross slide itself. However, the word once again is vulnerable. It is right in the way of the chuck. If anything comes out of the chuck, it's going to get whacked. All the swarf's going to be pouring on it, not to mention the hazard of the chuck jaws and you know, making contact. So again, for me, although that is a robust in terms of it's well mounted, it's not robust in terms of it's vulnerable. So that leaves me one option, and that happens to be the option I've gone with, and that is to put it roughly here, somewhere on this side. So now that I've picked what side it's going on, the next thing to do is focus in a bit and look at the landscape of what it can be bolted to and what might be in the way of it. Now, you can see that I've already done the work here. I've put in 1, 2, 3, 4, 5, 6 tapped holes, and that is going to be how I mount it. Now if I was to put this on, say here, okay, it's nice and inboard, it's not overhanging, but it's going to give me problems. First of all, reaching this, even if I can reach it, I'm likely to be bashing the scale. And also, by the time I got a cover on here, it will be slightly proud of this surface. And if you look at the design of this top slide, it requires a flush operation, and so looking at the arc this corner strikes as it pivots round, any mounting of guarding here would produce some fouling geometry. So it has to go this way, and I have picked a position of roughly here, and I will now show you what I've had to do to make this work, because it has involved a bit of engineering. Firstly, I have made a fairly long aluminium support. Now the profile of this is, as you can see, okay, this portion on the back mounts to the actual cross slide. The portion below is recessed. Remember, these pieces can move and they are adjustable, so I don't want to be actually bolting it to this. It is bolting to this face here, which is the main top of the cross slide, so it's bolting to this narrow face. All these bits underneath are in clearance. It's going to go approximately here, so it's strong enough to support this overhanging bit, and it has a lip running along to support from a top loading perspective, and also assist in alignment of the scale. Corresponding with that, I have made another piece. This is just an aluminium block. 2 counterboard holes from the top mount this to the saddle, and the corresponding holes line up with the reader, so the whole lot will sit on like this. The reader gets bolted through, and then I mentioned some guarding over the top. I have made a guard, piece of aluminium angle, and that will come on here, be held on to the top by countersunk screws, and that is my solution. So the whole lot will travel up and down. It's far forward enough that it doesn't interfere with the saddle lock or the swinging arc of the top slide. It's not overhanging enough to be a major hazard of vulnerability, and there's enough clearance for everything to slide without rubbing. So that is my solution. Now while I fit this, I thought I'd show you a few little clips of the manufacture. Op 1 complete, and I have established the machining datum. This is the surface that will bolt to the cross slide, and this surface will be on the top, and this is the surface that the cover will screw onto. I am now going to swap the clamps over to the other side, and I will then be machining the back clearance and the bottom face. Op 2 is now complete. The back clearance is done and the overall width is finished, so that's width, ends, and all the work on this face done. Now to reverse it and do some more work. This method of using plastic as a backer was taught to me by one of my early mentors, Andy Langley, and the main benefit of it is that in applications where you're using coolant, the shavings don't go mouldy. If you use wood as the backer, the bits of wood go in the coolant and get mouldy. On to the next side. From this angle everything can be seen: the cross slide reader and cover, the longitudinal scale, and all the cables now go downwards and are clipped to various positions. Also you can see I have fitted the attachment for the coolant stem, and the rubber tubing goes down to the pump, which I showed in part 1. Coming off the wall is the main display, and you can see this says Machine DRO. Now I have no links to that company, but I use them because they are UK based and they are very easy to get hold of. For instance, on this I couldn't work out how to change the resolution settings, and I was able to message them on Instagram and they came and told me what to do. So a company I like using, got no links to them, just my opinion. Now that the digital readout's installed, let's have a look at the tailstock and threading attachment. The tailstock now has all its underneath bits back on, and in addition to those I have made this brass spigot. Now I just spot face drilled and tapped an M12 hole in the bottom tailstock piece while it was off, and then I've just fitted this. Why is it there? Well, let me show you. This is the saddle and this is the cover plate of my digital readout protector. Now watch what happens when the tailstock comes in. That brass spigot has hit the underneath of the saddle and left me a 2mm clearance gap so that nothing hits the readout. So you can now see that this brass spigot runs in and hits the casting of the saddle. Now I know you can make a fancy version of this with a nylon tip to save the paintwork, but actually a hard stop in my opinion is more useful, because say you use an automatic Coventry die head mounted on the tailstock, you are relying on the saddle to make the die head open, so it runs in producing the thread, it then hits, and that is what causes the die head to open. So with a hard stop you get a consistent and settable opening point. So that is the threading attachment with all its covers back on. I will go into more details around that operation when I demonstrate the running of the lathe, although it probably deserves a video on its own. Now however I will show you around the machine and we'll have a look at some of the other things I have been working on. What is that thing behind my head? Yes, it is a digital inverter, but it's not doing the job you might think. Digital inverters are often used to give you 3-phase from a single-phase domestic supply, but that's not actually what I've got behind me. This workshop runs on an 11 kilowatt rotary phase converter, so I have no need to have inverters on in the individual machinery. Well, that's what I thought, because the whole thing runs on 3-phase. So when I got this lathe home, all I did was plugged it in and started it up. Now it runs, but this motor, if you do the calculations, the spike of current on the startup actually draws 70 amps, and that is enough to dim the lights in this workshop and probably to dim the lights of several surrounding houses as well. So I needed to do something about it, particularly because this lathe has no clutch. It's on or off, and as the spindle goes on and off, the motor goes on and off, so you're quite frequently starting the motor, equaling quite frequently dimming the lights. So this thing behind me is a digital inverter, but it's not converting a phase. All it's there for is to take 3-phase in and give 3-phase out, but in a controlled way, and it's set to give me a ramp up time of the spindle. So rather than it being straight on as soon as I put the forward lever into a position, it actually takes 2.5 seconds to ramp the spindle up. That greatly flattens this start-up spike, and as a result the lights don't dim. So that is what it's doing. Now this kind of thing is greatly beyond my expertise, and so I owe great thanks to firstly Duncan Ravenscroft, who helped me get the whole thing wired up in the first place, but also to Paul Compton. Paul is a YouTuber. I put a link to his channel in the comments, and Paul has a Harrison lathe at home and is used to running 3-phase equipment off a UK domestic supply, so he was instrumental in helping me work out all the little finer points. I'll go more into detail on that perhaps in a electrical video, but for now I'm just going to point out that this thing here is a digital phase inverter, and it is being used to smooth the startup current. This one turned out to be a touch too big. Yep, you guessed it, I was fitting a light. I got this out of a skip, and I've now mounted it to the wall, and it is offering some handy additional illumination of the work area. The guard has also had some work. I've made 2 new 1/4-inch plexiglass panels. I've fitted a knob off a bathroom cupboard, and I have also drilled and tapped some holes and fitted cap heads and lock nuts so that I can set the stopping position such that it's behind centre, so it stays up, but such that it doesn't go back far enough to whack the digital readout display. Slideway wipers. At the tailstock end of the saddle there's one here and one here. Sweeping across the front of the machine there is one along the cross slide here, and looking all the way to the front of the machine there is a different arrangement in the form of these long bed covers. So these are actually shielding the bed from swarf falling off the turning, and inside these long covers is another wiper assembly again, in addition of course to the front wiper. So that is the setup of bed wipers. Now I've only got one thing to say on this, and that is with regards to what you put in there to do the actual wiping. Now traditionally machines used felt. Alternatively, in more modern times they perhaps use rubber. Now the benefit of felt is that it hangs onto the oil and continuously lubricates the slide, but it does also tend to hang on to swarf. Swarf becomes stuck in it, and over time it becomes less effective at keeping swarf out of the sliding parts. The rubber, on the other hand, doesn't tend to hang on to the swarf so much, but it acts as a true wiper, and in that it actually wipes the oil away as well. So those are the things to think about. Now what I've actually done in this case is I've put the two together, and I have got a combination of felt and rubber on all the wipers, apart from these ones at the front, which is just purely a layer of rubber. If we look at the cross slide wiper, for example, you may be able to see that there is a layer of rubber at the front hugging the contours of the bed, and then there is actually a layer of felt behind it hanging onto the oil. So those are a few things to think about with regards to slideway wipers. Under each of the 4 corners is a floor pad, so that's a rubberized cork and then a piece of 3/8 mild steel on top, and using those adjusting bolts I will level the lathe in line with the Joe Piesinski lathe leveling video. Surprise item. I have been very fortunate in that a kind and very generous subscriber, who is remaining anonymous, has given me for this lathe a multi-fix quick change tool holder system. So this is the type that take these multi-fix tool holders, and this will see some great use on this machine and in videos, so thank you very much. Well, thank you for joining me at today's ribbon cutting ceremony. I'm grateful you were able to attend. The lathe in front of the camera has been a back burner project in this workshop for over 3 years, and it has been the main project in this workshop for the last 10 months. Over that time it has consumed over 500 hours work and has presented many conundrums, thankfully all of which have been resolved. I am extremely pleased this lathe is finished, and I look forward to being able to use it, and I hereby declare this lathe operational. Now I will proceed with the footage demonstrating the operation and controls. Spindle going forward. Spindle in reverse. Spindle speed is controlled by the operation of headstock levers. Bringing this lever either to the left or right engages the feed shafts and lead screw. And the direction of those relative to the spindle can be reversed. With the feed shaft rotating, motion of the saddle can be observed. The direction of travel can be reversed. Equally, the cross slide can be put into motion. And again, motion of the cross slide can be reversed. In addition to the feed shaft, the lead screw can also be used for saddle movement, typically for threading, and this is done by the use of the threading attachment. So that is that. A larger turning capacity has now reached this workshop, and I look forward to making use of it in upcoming videos. Apart from that, all I have to say is thank you for watching. I hope you found this interesting, and see you on the next video.